This is Darlington, on the shores of Lake Ontario, about 70 kilometers east of Toronto. It's one of Ontario Power Generation's 2 nuclear generating stations. And it's basically a factory for making lots of electricity, enough to power a city of around 2 million people. That's about 20% of Ontario's electricity needs. The building is divided into 2 main areas along its length: the nuclear side with the reactors, and the conventional side with the turbine generators that make the electricity. There are 4 generating units at Darlington, units 1 to 4, each with a reactor and a turbine generator. Each unit can generate 935 megawatts of electricity. Darlington produces electricity using the heat that comes from splitting uranium atoms in a process called nuclear fission. The fuel is naturally occurring uranium that's processed into small pellets. The pellets are sealed into metal tubes, which are welded together to form a fuel bundle. The fuel bundles are then inserted into a large tank called a calandria, which is the heart of the nuclear reactor. In CANDU reactors, a special kind of water called heavy water flows around the fuel bundles. Heavy water is found in all water, rivers, lakes, and oceans. On average, 1 out of every 7,000 drops of water is heavy water. It's 10% heavier than ordinary water because it incorporates a heavy form of hydrogen called deuterium. The heavy water slows down tiny particles called neutrons, so they are more likely to hit and split the uranium atoms. A chain reaction of splitting atoms releases tremendous heat into the heavy water. The heated heavy water flows through a closed-loop system that's pumped through the reactor to a set of steam generators, where it transfers the heat to ordinary water. When that water boils, it turns into steam. The steam is transported at high pressure through pipes to a large turbine, where it pushes the blades and turns a shaft connected to a rotor in the generator, causing the rotor to spin. The spinning rotor is a large electromagnet that produces rotating magnetic fields. These fields move across coils of copper wire in the generator, producing electricity. The electricity is fed into transmission lines that carry the power from Darlington to people's homes and businesses. All used fuel is carefully stored in safe and secure areas that are constantly monitored by the Canadian Nuclear Safety Commission and the International Atomic Energy Agency. So let's take a tour of Darlington. Before going into the station, everyone has to pass through a security building that operates a lot like an airport security system. There are machines to check for explosive chemicals, X-ray machines, and metal detectors. Then everyone has to pass through a turnstile where their security card and their individual hand-bone structure must match. At all times, highly trained security staff inspect every person and everything entering and leaving the station. Then, all personnel pick up devices that are issued to them to constantly monitor for radiation while inside the station. Safety is the #1 priority at all Ontario Power Generation facilities. So everyone working in the station must have the proper protective equipment: safety glasses, hard hats, safety boots, gloves, and hearing protection. Visitors must also wear safety equipment. The main entry for the station is through an area known as Unit 0. This is where the common systems for the entire station are located: heating, lighting, ventilation, and the operations control room. Also located in Unit 0 are the mechanical maintenance shop, where experts in welding, machining, and pipe fitting work on equipment. The control maintenance shop for the experts in electrical, instrumentation, and electronic systems. And stores, where people pick up the tools and parts they need to do their job. The station is divided into zones according to the location of systems and equipment to prevent the transfer of radioactive materials. Whenever people or equipment move from zone to zone, they monitor to ensure no transfer of radioactivity. Let's start at the beginning of the fission process, where heat is released from the fuel. Each of the 4 reactor buildings is made of heavily reinforced concrete, with external walls 2 meters thick. When a reactor is operating, no one can enter the reactor vault, but when it's shut down for maintenance, radiation fields decrease and trained staff can safely work here. Technicians put on protective equipment, log in with their tools, and then access the reactor through the airlock system. The reactor consists of a large, heavily shielded vessel, or calandria, which contains 480 fuel channels and 6,240 bundles of uranium fuel. We're now looking down on the top of the reactor vault. The process of nuclear fission draws the heat from the fuel to boil ordinary water into steam. All that steam is transferred over to the turbine side of the station through large steam lines. So this is the turbine hall. It's almost 4 football fields long and 19 stories high. All 4 turbine generating units are located in this one giant area. You can see the color coding. Unit 1 is red, Unit 2 is yellow, Unit 3 is green, and Unit 4 is purple. This color coding extends all the way through the systems for the unit and into the control room. Since all 4 generating units are identical, the color coding ensures correct unit and system identification. The turbine blades are shaped like a fan, where steam enters and turns the blades. In the center is a connecting shaft that rotates at 1,800 times a minute as the steam pushes the blades. At the very end is a relatively small piece of equipment, the actual generator where the electricity is made. From here, it's out to the grid and into homes and businesses. So finally, we come back to Unit 0 and the control room. Mission control for the whole station. Every important system in the plant is monitored and controlled from this room by highly trained and certified staff. Authorized nuclear operators go through an average of 8 years of high-level training and testing to become fully certified by the Canadian Nuclear Safety Commission. All Darlington staff are lifelong learners and spend up to 20% of their time in continual safety and job training. OPG nuclear generating stations use the Defense in-Depth Safety philosophy that sets the highest standards for plant design and operations. For critical components and systems, backup devices ensure redundancy at all times, as well as fast-acting shutdown systems. There is a secondary containment structure called the vacuum building. This 71-meter-high, 24-story cylindrical concrete structure is connected to the reactor buildings by a pressure relief duct and is a unique safety feature of the CANDU system. So, that's a look inside the massive machine that is the Darlington Nuclear Generating Station. But ultimately, that's not what makes the power. It takes people. Over 2,500 highly trained and skilled staff work at Darlington. 24 hours a day, 365 days a year. Supplying the homes and businesses of Ontario with safe, reliable, clean electricity.